Welcome back, class. We're going to continue on part 4 in this video lesson. And in this video lesson, we're going to talk about the last 3 things in this topic: fuses, circuit breakers, and switches. So, what's a fuse? A fuse is a short piece of wire. You can see it here. So they look like this, but if you open the label and see what's inside, it's just a piece of wire with a certain diameter which will become hot and melt when the current is too large for it to handle. So what is a fuse for? A fuse is a safety device and it ensures that the current in a circuit will not exceed a certain value. If the current exceeds a certain value, it will melt the fuse and hence current flow will stop, and therefore the circuit will be safe. When this happens, we say the fuse has blown. So fuses in general prevents excessive current from flowing inside the circuit. If the current gets too high, cables can burn out, fires can start, and the circuit can be damaged. So how does it work exactly? Fuses have a lot of different ratings. There's the 1 amp one, 2 amps, 5 amps, 10 amps, and 3 amps. For example, a 5 amp rating fuse will melt if the current passing through it exceeds 5 amps. Let me give you another example. Let's say you have a circuit. When the circuit is running normally, the current inside the circuit, let's say, is 10 amps. Okay, so this is the operational current. So this is when you turn on the appliance or the circuit, this is the normal current inside the appliance. And let's say the circuit is equipped with a fuse rating that is 12 amps. Let's say suddenly there is something wrong with the circuit, or maybe there's a lightning strike nearby and then suddenly the current jumps up from 10 amps, now it becomes 15 amps. Okay? Now, because the current inside the circuit is higher than the rating of the fuse, it's too much for the fuse to handle. The fuse will melt, or we say it will blow up. Okay, it doesn't blow up actually. The wire melts and then it just cuts off. So the fuse melts and then it'll stop the current flow inside the circuit instantly. That way, the circuit is safe. Okay, so that is what a fuse does. It will melt if the current gets too high. The circuit diagram drawing of the fuse has many versions. There's one that looks like this, one that looks like this, and one that looks like this. But the most common one, and especially the one that you will see often in O-level exam, is this one. Okay, so make sure you know what the fuse looks like in terms of the circuit diagram drawing. Now, for safety reasons, the following points below must be considered when selecting and installing fuses. So it's very important for any appliance to have a fuse installed. And you need to be able to pick the right fuse for your appliance. So how do you pick the right fuse? When selecting and installing fuses for an electrical appliance, the fuse should have a current rating just slightly higher than the maximum current of an electrical appliance. For example, if a circuit uses 4 amps of current, then it is wise to install a fuse whose value is slightly higher than that, and the best one would probably be 5 amps. And when you connect the fuse, it should be connected to the live wire so that the current will have to pass through it first before reaching the appliance. Thus, the excessive current will not damage the appliance. So we'll talk more about the second point in the last part of this video. Now, I'll elaborate why you need to have a fuse that is slightly higher and not too high. Let's use this example. You have a circuit that has an operational current of 4 amps. So that's when you turn on the circuit. This is how much current that is inside the circuit normally. And this is the normal current. And let's say you install a 100 amp fuse, right, for this specific appliance. Now, let's say there is something wrong with the circuit again, and now suddenly the current jumps up very quickly to 10 amps, and this is a lot of current for that circuit to contain, but because this current does not exceed the rating of the fuse doesn't do anything. And there's this large current going through the circuit, and then the circuit will become damaged, or worse, it will melt, or there's fire starting. Okay, so that's why you need to pick a fuse rating that is slightly higher than its normal operational current. What if you pick a fuse that is too low? Let's say your operational current is 4 amps and you pick a fuse that is 3 amps. What's going to happen? Well, what's going to happen is that every time you turn on the circuit, it will instantly blow the fuse. So because every time you turn it on, there's 4 amps inside the circuit, and the fuse can only handle 3 amps. So every time you turn it on, the fuse will blow, the circuit doesn't work. So only pick fuses that are slightly higher in rating than the maximum current of an electrical appliance. Let's do an example here. A hot water heater is rated 2,880 watts and 240 volts. Calculate the operating current and suggest a suitable rating for a fuse to protect the heater from heating. Now we want to find the current. What is given to us here? We are given the power, we are given the voltage, and we want to find the current inside this heater when it's operational. What formula we can use? It's P equal to IV. This is the formula we should use to find the current. P is 2,880. Current is the unknown value, and V is 240. You rearrange this formula, and you should find that the operating current is 12 amps. Okay, so this is the operating current. So what fuse rating we should pick for this water heater? So if you want to answer this question, which fuse rating we should pick for this heater? Okay, so for that, we can select the fuse rating that is available to us here. Our current rating was 12 amps, so which one is suitable for it? We pick the one that is slightly higher, so 13 amps. Okay, even if you pick 15 amps, that is still good. So either 13 or 15 amps is good. Okay, so fuse, we pick the 13 amps one or 15 amps. So both are actually good fuse ratings for this particular heater, and that's the answer. Right, so let's go back to earthing a bit and talk about what happens if you have both the earth wire and fuse connected to the appliance. Is this a bad thing or is this a good thing? This is actually a good thing. The earth wire keeps the appliance safe. The fuse also keeps the appliance safe, so you have a double safety feature here. So, in the event of a fault, the electricity from the metal body will pass through the earth wire and go to the ground, keeping the metal body of the appliance safe in case you are touching it. Since the earth wire has little to no resistance, there will be a sudden large current. This causes the fuse to blow, preventing any further current to flow. Okay, so that's actually a good thing. Not only the excess electricity goes through the earth wire and not to the other parts of the appliance, but the current is instantly cut off because of the fuse. The next thing we'll talk about are circuit breakers. So circuit breakers are safety devices that can switch off the electrical supply in a circuit when there is an overflow of current. So you probably have seen this at your home before. Every time the electricity trips at your home, what do? You go to your circuit breaker and then switch it back to its on position. When someone say there is a trip in electricity, they mean that circuit breaker has tripped. The circuit breaker has cut off electricity in your home because there's probably a dangerous current going around inside the circuits in your home. So you can think of circuit breakers like fuses, but in this case, it is a resettable fuse. It can trip and then turn back on, and then it can trip again, you can turn it back on again. Whereas fuses, once the fuse has blown, you have to replace the fuse. If the fuse is blown again, then you have to replace it again. So it can be quite a lot of work. But circuit breakers, you can just flip the switch in order to turn the circuit back on. Okay, so without the circuit breaker, this surge of current can cause damage to home appliances or even start a fire. This is an example of a circuit breaker. In the figure above, you can see the circuit breakers labeled with various currents. each current is connected to a circuit inside the house. So I'm sorry it's not clear, but there should be a label or a rating showing how much the circuit breaker can handle before tripping. So this one is actually 20 amps. So all of them are actually 20 amps, okay? And each circuit breaker is connected to a part of the house. Okay, so maybe this one connects to the dining room, maybe this one connects to the toilet. Each switch is connected to a part of the house, and usually you have a main circuit breaker here, and this one controls everything basically. If this one trips, everything trips. Okay. So, how does it work? Basically, again, it's the same as the fuse. If the current flowing through a breaker exceeds the limit value of the breaker, in this case, you have a 20 amp rated circuit breaker. That means if the current is more than 20 amps, then the circuit breaker will trip. So in Malay, we say that karannya tertrip. Okay, tertrip karannya. So the circuit breaker is tripped, the switch goes down. This electric supply to that part of the house will be cut off for safety reason. Okay. The last thing we'll talk about are switches, specifically the placement of switches and fuses. So when you are connecting or when you are designing your own circuit, when you are creating your own circuit, this is a good practice to have. It is always safer to have switches and fuses connected to the live wire. So, in order to explain why this is safer, imagine trying to change a light bulb with the switch and fuse connected to the live wires. For example, here. So, you want to change the lamp and then you switch it off. So, that means the electricity can only reach this part of the switch. It cannot go any further. So, that means when you are touching the lamp, it is definitely safer for you to touch the lamp. This switch is off, but voltage is 230 volts everywhere along the live wire, the fuse, and the top terminal of the switch. From bottom terminal and along the bulb and neutral wire, voltage is 0, so it's safe for us to change the light bulb. You will see in this second example here, now we have the fuse and the switch on the neutral wire instead, not on the live wire. So this switch is off, but voltage is 230 volts everywhere along the live wire, the light bulb, and the bottom terminal of the switch. So there is still voltage running, or electricity could be running along those lines there. So in this case, if you want to touch the lamp to change the lamp or something, light bulb is not safe to touch. So in this case, it is less safer than if you put the fuse and the switch on the live wire. And also another point here, if the fuse blows, the lamp and switch are still at 230 volts. So even if the fuse breaks the current, you will still have potentially electricity running almost throughout the rest of the circuit. That's why having the fuse and the switch connected to the live wire, like in this first example here, is much safer because you can, whatever happens, electricity can be cut off from most of the rest of the circuit. So, to summarize this video lesson, we looked at the final 3 things in this part 4: fuses, circuit breakers, and switches. Remember what is a fuse for. A fuse prevents excessive current from flowing. And remember that fuses are rated at different ratings, and it has this circuit symbol. And very important, if you want to select and install a fuse, make sure you have a fuse rating that is just slightly higher than the maximum current of an electrical appliance. And then make sure you know what a circuit breaker is for. So circuit breakers are safety devices that can switch off the electrical supply in a circuit when there is an overflow of current. So it's basically a fuse that is resettable, and you can turn back the circuit on once everything is safe without actually replacing anything inside the circuit. And then make sure you know where to place the switch and the fuse. the switch and the fuse are best connected to the live wire because that's the safest arrangement that you can have for these two components and for the circuit. And that's pretty much it for this chapter of practical electricity. Next chapter, we're going to look at magnets and magnetism.